Hello friends, in this video we are going to talk about accuracy and precision and errors. I'll just list down topics: accuracy, precision and errors. Now what is accuracy? What is an accurate measurement? An accurate measurement is the one which is very close to the true value. Okay, now this true value is something that someone may tell me. For example, cap of this marker has got a diameter of 15.4 millimeter. Okay, and if I make measurements which are like 15.41, 15.40, 15.39, this kind of measurements. Now these measurements maybe I can say they are very close to 15.4 centimeter. Okay, so that means my measurement is accurate. Okay, but then what about my measurements being precise? Okay, if all the readings that I take, they are more or less close to some value. For example, I make measurements of 15.41, 15.40, 15.41, 15.42. Now if you see all of them, they are quite close to 15.4. Correct. So I would say they are precise. Or then I might have got readings which are 15.51, 15.50 and 15.51 again, 15.52 here. Okay, now if you see these readings, are they close to 15.4? No, the difference is very large. Okay, but the readings, they are quite close to each other here, the readings in themselves. Now what might be the reason here? The reason might have been that there is 0.1 millimeter is some zero error over there. Zero error might have been 0.1 millimeter. So all the readings, they are greater than what it should be by 0.1 millimeter, and then that 0.1 millimeter is causing the readings to change. Okay, but still if I talk about the set of these readings, they are quite precise. Okay, so a precise measurement may not necessarily be an accurate one, whereas here if you see, the readings are precise and they are accurate too, because they are very close to the true value. Okay, so again the question of selecting proper measuring instrument, okay, that would tell you whether the measurement is accurate or precise. Okay, now let us come to errors. Now what are errors? Error is deviation of your reading, okay, deviation of the measurement taken by you from the true value. Okay, so if my true value is this and I have measured 15.41, correct, then 15.4 minus 15.41, and I'm taking modulus of that. What is modulus? I'm taking whether it is positive or negative. I'll just take positive value of that. So mod of that would be, how much is that? 15.41 minus 15.4, it would be 0.01. Correct? So 0.01 is the difference between my true value and the measured value. If I have 15.42 here, then it would be 0.02. If I have 15.39, so again it is going to be minus 0.01, but then I'm taking modulus of that, so that minus 0.01 is going to be again 0.01, only positive values. Correct. So these are my errors. Okay, error in the measurement. Okay, but then you know what, we have certain procedure in while experimenting we follow certain procedure. And what is that? In experimenting I don't know this, no one has told me the true value. Okay, so what do? I do something like this. Uh, I take multiple readings. Okay, so I have to measure, let us say, diameter of a sphere. So I take my D here. Okay, so my first reading, second reading, third, I'm taking only 3 here. Okay, my first reading is 13.21, the second reading is 13.19, and third reading would be 13.23. Correct. So now what do? So this is my D1, D2 and D3. Okay, I take summation of that, sigma D, and that is equal to, I'll be adding all 3 of them, so it would be 12 plus 1, 13, and this would be 39. Correct. 39.63. How many readings have I taken? I have taken 3 readings. So my average, I would call it D bar, would be sigma D upon n. So that is equal to 13.21. So my average reading is 13.21, and now I'll take this as my true value. Correct. Then the difference between the true value or the mean value and my individual reading. Okay, so that would be my absolute error in the first measurement and in the second and in the third one. So 13.21 minus 13.21 mod of that. Then here 13.21 minus 13.19, 13.21 minus 13.23. Correct. So this first one is going to be 0. Now second one is going to be 0.02, and third one is going to be again minus 0.02, which would be again I'll be adding positive sign to that, so 0.02 here. Correct. So then 0, 0.02 and 0.02 there, they are my absolute errors. Okay, so the type of error, absolute error. Okay, now what do? My next one is, for calculation purpose, then I find mean absolute error. For mean absolute error, what do? I would say, I would call this delta D here. So my delta D1 is 0, delta D2 is 0.02, delta D3 is 0.02 again. So what I'll do for mean absolute error, delta D, I would say delta D bar. Like I have used D bar here for average of D, I'm going to use delta D bar, and that is going to be equal to delta D1 plus delta D2 plus delta D3 upon 3 again. So that would be equal to how much? So 0 plus 0.02 plus 0.02 upon 3. So that is going to be equal to 0.04 upon 3, and that would be 0.01333 something. So 0.013, that is my delta D bar. Correct. Now this is my mean absolute error. Now what do? If I divide this mean absolute error by my average value or mean value, correct, then that would give me relative error. Okay, so relative error is equal to delta D bar divided by this D bar, that is the mean value. So that is my relative error. And if I express this relative error as a percentage, then that would be percentage error in measurement of diameter. Correct? So that is percentage error. That is relative error multiplied by 100, and that many percent. Okay, so let us do it again. I take my measurements. I take 3 readings, then I add them, I divide them by the total number of readings. Now here my n is equal to 3, so I am going to divide this 39.63 by 3 and I get 13.21. So this is my mean value, 13.21. Okay, now from this mean value I subtracted individual reading here, 13.21 minus 13.19, 13.21 minus 13.23, and I got my absolute errors. After absolute error, I find average of that. That gives me mean absolute error. After getting my mean absolute error, I divide it by my mean value. Okay, so that gives me relative error, and when I multiply relative error by 100, that gives me percentage error. Okay, so that was about calculating different types of not, I wouldn't say different types of errors, but then different values. Okay, values of this error calculations. But then what is the reason for errors? What does what introduces errors in my measurement? Now the reason may be faulty apparatus, reason may be not very skilled experimenter, the reason may be setting problems, the reason may be changes in temperature, change in pressure, okay, change in the surrounding, okay, or ambient conditions you can say. But then depending on the reasons, we classify errors into generally 3 types. One is systematic error, the other one is zero error, third type may be random error. Now, random errors maybe you cannot predict exact reason for that. Okay, systematic errors may be because of wrong setting, or systematic error may be because of some zero error in the instrument. Now for example, this vernier calipers I have, okay, I am making both the jaws meet each. So zero of my vernier scale doesn't match with zero of my main scale, correct? So that may be the zero error. Now if it is on left side, that means whatever reading that I am taking, I am getting a smaller value than what it is, correct? And if it is on the right side of the zero of my main scale, then I am getting greater value than what it is. So then considering those conditions, you have to either add or subtract that zero error so that you get more I would say more accurate reading, correct? Anyway, you are going to get precise readings, okay, but then for improving the accuracy, you need to add or subtract that zero error. Other errors are, I would say least count error. The least count error would be because of the least count of measuring instrument. Now for vernier caliper, I have 0.1 as my least count, but then if I am using a normal 15 centimeter scale, of which the least count is 1 millimeter, then the error that might be introduced would be something like half millimeter here and there. I am saying half millimeter here and there because I can estimate that the particular reading that I am taking, it is when I consider the thickness of 1 millimeter, okay, so 50% on the other side, that would mean it is greater than half millimeter. But then again, the calibration, those lines have certain thickness, correct? The lines are supposed to have zero thickness, okay, but then practically it is not possible making scales like that, correct? So in a nutshell, we can say that the errors can be systematic errors, errors can be least count errors, errors can be random errors, errors can be introduced because of change in temperature, change in pressure, or then finally something happening because of lack of skills of the experimenters, correct? In the next video, we are going to talk about combinations of errors, that is if a certain quantity is sum of two quantities, then what is the effect on the that resultant. We'll be checking that in the next video. Thank you so much.